We're not going to talk about real zeros because when we're talking about polynomials, we really want to investigate and analyze the graph. And we're talking about all different types of analyzing. So the first thing is a real zero. So what I need to know first is what is an intercept. Well, an intercept is where the graph crosses an axis. So it could either be the x-axis or the y-axis, so I can have a y-intercept or an x-intercept. Okay. Y-intercepts we only have one of. X-intercepts we can have many. Okay. The zero of a function is actually x-intercepts. Because when you cross the x-axis, all along the x-axis here, what is y? Y is 0 for any place across the x-axis. And that gives me a zero of a function. Remember, a function is y is some function of x. So if I want to know when is a function 0, I want to know when is y 0, and I need to find my x for that. So a real zero means it has to be a value that's real, right? So if I have a function f, and I have r as a real number, and I know that the function f evaluated r is 0, then r is a real number. R is a real zero of f. So that's my definition of a real zero. So I need to know, it's really my values of x that give me f of x is 0. However, the important part is we're talking about real, so r has to be a real number. Can't be another kind of number. So if I look at these, think about what we said. We're going to talk first, we talked about our definition up there. So r is a real zero of f of x. So I know that. And we talked about when f of x is 0, what do I know? It's an x-intercept. So I know that r is an x-intercept for the graph. So now what I'm going to tell you is x minus r is a factor of f. And if I want to think about that, think about when you factored a quadratic, you'd say maybe x minus 1 and x plus 2. Then, and I said equal to 0, if I asked you what the solutions were, you said each of these equal to 0, and those were your solutions. So if I have x minus 1 is 0, that means that x is 1. So that gives me my r, and that would be an intercept. The last statement that means the same thing is r is a real solution. To my equation. And remember what I was saying here is I was looking for a solution. What we do is we like to factor, set equal to 0, use a zero product property, so each product equals set to 0. If it's 0, the whole product is 0 of each factor, and then that's just really a solution. So I know how to factor, so I know how to get my zeros. But what if I told you that my zeros were 1, 2, and 3? How would I find what's my function f of x? Well, I can go backwards. Remember, because I said if it was x minus 1, I set it equal to 0. I got x equals 1. So I know that it's x minus each 0. So if I had a 0 of negative 2, it would be x plus 2 as a factor because I have x minus negative 2, and 2 negatives become a positive. Then what I want to do is I want to expand it. So you should expand it and check, but we should get x cubed minus 6x squared plus 11x minus 6. So what you're going to do is you're going to FOIL the first two, right? You get x squared minus 3x plus 2, and then you would multiply that by x minus 3, and you would get that final result. So you can go both ways. You can find your zeros by factoring, or if you know your zeros, you can write it in factored form and then expand it.